And welcome everyone to another CW talk. Hopefully many of you have attended some of these in the past, but if you haven't, it's framed more in the style of a debate. The idea is to pick a particular topic, to have some people talking for either side of the motion, and then for us all to have a chance to debate. So rather than lectures and questions, the idea is really that once we get to the debating session, you'll be able to input some thoughts and views. The panel can mull them over. And we're going to have a vote in advance of the debate, and we'll have a vote after the debate, and we'll see whether people's minds have been changed by what they've heard. So I'm William Webb. I am one of the curators of these CW talks. There's a couple of others. I think we'll be introduced to them briefly later on. And I'm sure many of you know me, so I won't spend too much time introducing myself. A few important housekeeping things. I don't have to point out where the emergency exits are this time, but I do have to tell you how the platform works, and in particular, if it freezes, the solution is typically to refresh your page rather than assuming that we've all got stuck at our end. So do try a refresh. And there's a panel on the right-hand side that you can use to ask questions. Ask them at any time you like. We won't get around to answering until we move through from the opening statements to the questions, but I'll be able to see them as they come in. So feel free to fire them at any point in time. And there is a live support feature in the bottom corner of the screen. Okay, let's get the poll going. Adam, could we have the first poll up, please? I'm putting it up now because it takes a while to work through and to count. So hopefully this can be happening in the background as we go through some of the opening material. So you need to go to a website. You can see it on the side there, slido.com. And on that website, there'll be an option to enter a code for the event. You can see the code there, 360898, and that will give you the option to vote. And we'll give you a few minutes to do that whilst I'm going through the rest of the slides and introductory material. And then hopefully we'll have an answer before we get to the first speaker. And then we'll repeat exactly the same poll as we get towards the end of the session today, see how we get on. So the question is very simple. Let's have no more Gs. If you agree that that is your preference, then say yes. If you think that actually there should be more Gs and we should have a 6G, then answer no, and we'll take it from there. Okay, let's move on. I think we can take that one down now, Adam, for the moment. Okay, so many of you know CW, but not all. It's a not-for-profit organisation, very much member-led, owned by the member, has a board elected by the membership, and the board very much sets the overall direction and policy for CW. You can see the overall objectives there to network, learn and grow. And I think it's important to realise that whilst the origins are very much Cambridge-based, now 70% of the network is outside of Cambridge, and indeed 13% is international. So we're a pretty broad network. And whilst the W originally stood for wireless, we also cover a much, much wider range of topic areas now. Forthcoming events to note, in particular, our annual CW Tech, Technology and Engineering Conference, 7th and 8th of July online, engineering 5G private networks, a pretty important topic area. Okay, well, the whole of this event is sponsored by UK 5G, and I'd like to introduce Bob Driver, who's also one of the curators of these talks, to take us through a little bit about UK 5G. So Bob, it's over to you.
Thanks, William, and it's great to be involved in this and to be working along with the excellent CW team and to be helping in creating this talk. It's sad that Professor John Hain can't be here because he was the guy that came up with the original idea for the talk. So because UK 5G is supporting this, it falls to me to say a few words about UK 5G. And UK 5G is part of the DCMS test beds and trials program, where the innovation network that's bringing together a lot of the activity that's happening around 5G and advanced networks in the UK, part of the DCMS £200 million program that started in 2017 and is going to be finishing in next year. And it's grown from an early projects that involved universities in 2017 through 6 projects that were the initial projects, and now it's over 30 projects involved in this program. And you can see on that diagram there that there's projects organized by sector and location. So UK 5G is an impartial network of networks. We're trying to pull together a whole load of organizations and intermediary organizations that are looking after this subject, and also projecting what is happening in the UK. Internationally, here are a few numbers for UK 5G. It keeps on growing, it's active, it's vibrant, there's lots going on. It's led by Cambridge Wireless, but it also has support in core delivery partners from the Knowledge Transfer Network and the TM Forum. It also does a magazine. If you want to get a magazine that we produce every quarter, you can register on the site. And if you want a physical copy posted to you, you can have that luxury. The last one, this one, was 64 pages long and will tell you everything that's happening about 5G in the UK. Also, we have a supplier directory that we started just about a year ago, just over a year ago, and it now has 142 companies that are looking at providing 5G technologies to the marketplace, and it's all the way from chipsets to content providers. It's useful if you're part of a company and you're not on that supplier directory. It's free, you can come on it for free, and it's really useful in terms of promoting particularly UK companies overseas, but also connecting supply side companies, which is obviously the supplier directory is by its nature supply side, with the demand side verticals that we're focusing on, particularly manufacturing, creative, transport and logistics, etc., etc. So that's just about me. I'm very interested to learn more about in this debate. I mean, obviously UK 5G by its very name was created by the UK government to help accelerate productivity gains through advanced mobile networks, which back in 2018 had the sobriquet 5G. And to what extent the aggregation of all those technology developments into 1G is helpful, or whether it's a marketer's dream, let's find out. And back to William. Thank you very much.
Thanks very much, Bob. Here's what we're going to do. We're going to, okay, good, I overshot on the slides. So as Bob mentioned briefly, there are 3 of us that curate these talks. You can see the full cast there. And just to say, we're always interested in people's thoughts on topics, and particularly topics that are sort of crisp and offer a nice kind of A or B type of argumentation. Now, life's never quite like that, but if anyone's got any ideas for anything they think would be good, feel free to email any of us, or indeed put it in the chat on the system, and we can pick that up. Okay, so we are going to have the 4 speakers, each spending up to 15 minutes, and I told them no more than that because I do want to get onto the open forum to set forward their thoughts. So first of all, Stephen and Phil will talk in favour of no more Gs, and then Adrian and Rahim will talk in favour of more Gs, and then we'll open it up to questions. Before we do that, Adam, do we have the results of the poll, the introductory poll? Sorry, I should have given you a bit more warning than that. Okay, so interesting, 63% for no more Gs and 37% for more Gs. So Rahim and Adrian, it's up to you to make up that ground in the next hour or so. Fantastic. Okay, let's go back to the slides then. And I'd like to introduce first Stephen Howard. Stephen joined the Communications Chambers this year, where he provides analysis of strategic and regulatory issues. Prior to that, he spent 14 years as Global Head of TMT Research at HSBC, where I'm sure many of you will know him, and a speaker at many of our events in the past. So let me pass over to Stephen. It's all yours.
Well, thanks very much, and thank you everybody for your time today. Having seen the poll, I'm minded simply to declare victory and move on. But I suppose I should make use of the 15 strictly limited minutes that I've been allotted. So let me begin by talking a little bit about how I approach this topic. I was reading a document on 6G. I won't be any more specific than that, but it was discussing the technology, its various components, and also the policies and the strategies that are going to be required if 6G is to reach its full potential. And as I was going through this material, I suppose I found myself wrestling with really two quite different responses and thought processes. Now, the first of those, and I need to be very clear here, is simply admiration, right? Admiration for the astonishing sophistication and ingenuity of the technology that is behind 6G. So I want to make it absolutely plain that I think the technology, looking back over how it's developed in the course of my career, it truly is remarkable. But I had a second strand of thought at the same time, amidst all these forests of 3-letter acronyms in the documents, 4-letter acronyms, indeed even 5-letter acronyms. I found myself wondering, whether the document itself wasn't the product of some ingenious algorithm. Why was I wondering that? Why was I suspicious about that? Well, look, I admit the document in question wasn't precisely a piece of purple prose, but frankly, it didn't need to be. But what really struck me about it was the way in which every section of the report was this seemingly endless parade of technologies and their labels. Resembling almost some kind of colossally dysfunctional game of bingo or something. Now, I'd accept that. Clearly in a document about 6G, of course, it's going to be all about the new technologies and it's going to be involving a lot of acronyms. But there does come a point where I think as a reader, you start to wonder whether all the acronyms and the buzzwords aren't starting to crowd out something else, of which I was really struck there was comparatively little mention of in this document. And that is to say, there's little mention of real, practical, actual, believable, credible applications. So I feel that today I have a bit of a difficult balancing act to perform. Right, the last thing I want to appear as is some kind of Luddite. As I say, I think that the capabilities of much of the technologies here are remarkable, and I'm sure that further R&D will bring rewards in terms of further pushing the envelope of what's possible. However, right, given the sums that are involved, given the importance of getting this whole ecosystem right, I think that we really need to refocus on what is in a sense the most fundamental question, which is, what are we actually doing all this for? And I have what I suspect maybe is a slightly old-fashioned answer to that. We're doing it for the customer, and by the way, I mean the end customer. I don't mean if you're a telecoms equipment vendor. I don't mean a network. We're doing this for the end customer, the end consumer. Perhaps a business, etc. What we're about is finding solutions for their challenges, and to address their needs. And what we have to think about is, what are those challenges? What is it that they need to do that they can't at the moment? This in turn raises some sort of slightly thorny questions, because there is a widespread notion in certainly the technology sector that the customer doesn't really know what they want, and therefore that there's kind of no use asking them. A consumer focus group, for instance, is never going to come up with the idea of the smartphone. And meanwhile, looking at telecoms, there's a commonplace there that your customers don't necessarily figure out what to do with new infrastructure until they've been provided with it. So the so-called build and they will come philosophy. Now, I don't think that either of those ideas is completely foolish. But nonetheless, if cellular operators have committed billions and billions of pounds to deploying the previous generation of new technology, and yet the real drivers of bandwidth requirements remain what drove demand for the generation before that, i.e. video streaming, then I think it is perhaps time to wonder where the disconnects lie between those charting our future technological roadmap and those who are actually consuming the resulting services. Now, I don't want to pretend to you that I have all the answers to that, but let me highlight one particular conundrum that I think should be towards the forefront of our thoughts, and that's why cellular IoT hasn't been a bigger success. Because I think, IoT itself is a truly great idea. Things that are able to intercommunicate, a network of things, there ought to be enormous scope to run manufacturing and logistics operations more efficiently, not to mention what you can do with transport and utility networks. All of these ought to function much more efficiently when their components can talk to one another. So the question is, why isn't it everywhere and in everything already? I'd accept there's some of it around, but a lot of it actually uses technologies like Wi-Fi, so it's not cellular. And William's asking for questions for future debates. Well, this actually strikes me as a fairly fertile question to investigate in a whole session of its own. So I'm not going to be able to sort of give you an encapsulated answer to that, but nonetheless, I'm pretty clear that the answer isn't that cellular IoT would be ubiquitous if only networks were 5 times faster, or if only networks were 5 times more accurate, or if only they were 5 times cheaper, or even if only they were 5 times more energy efficient. Albeit that, I dare say all the above considerations would doubtless contribute. I think the real reasons why something like cellular IoT hasn't fulfilled its potential are a lot more complex than that. They involve things like organizational inertia. Perhaps deployments need to reach a certain critical mass before the benefits properly accrue. There are going to be lots and lots of issues. But what I would suggest is, that's actually where we need the R&D. If we could overcome these types of practical hurdles, then I suspect that would deliver ROI that's a lot better than what you would get from instead throwing the money at hoping that if we just do one last push in terms of a further G, that somehow the technology is already near miraculous capabilities, with that extra push will somehow get us over the the hump that's required to get mass deployment. So I think to encapsulate that in one even briefer question, my question is, why is it that the telecoms ecosystem just hasn't really been able to work out how to leverage the already terrific platforms and capabilities that we have in this area, things like NB-IoT? If we don't have answers to that kind of question, then I think pursuing further Gs could be a bit of a fool's errand. So that's I suppose, my most fundamental objection to further rounds of Gs. I think it has a tendency to leave the most important person out of the discussion, and that's the customer. But there are other reasons besides, and let's quickly run through some of those. First, I think all of this is getting riskier and riskier. Telecoms requires billions in capital. I can assure you that financial investors are heartily sick of the sector and its dismal returns. As William mentioned, I was an equity analyst in a previous life, and I increasingly met with investors who are of the view that operators should just walk away from new spectrum issuance. You might think that's an incredibly foolish or short-termist stance for them to adopt, but the point to make here is that the people who provide the capital really are at the stage where they're actively advocating this. So I think if we have another G with lackluster demand response, then the question that we're posing in this debate is liable to become entirely academic. Second, I think the hype cycle that tends to build around each new technology generation encourages a kind of misallocation of resources. I think it invites disappointment. I think it helps fuel spectrum prices. And the exorbitant cost of finite duration licenses is one of the reasons why returns in Europe are so abject in the mobile sector. And that in turn is a fundamental reason why investors are determined to constrain operator capex. A third and closely linked point to that is that the Gs are too readily misunderstood in the policy arena. I think there's an enormous temptation, understandable temptation for policymakers to try and associate themselves with the white heat of technology and mandate deployment. And, I think that ignores the market. There is a certain place for interventions, but I think there are good reasons why we have markets. It's the market's job to figure out where there's demand as communicated by a price and to try and satisfy it in the most efficient manner. And I think those decisions are very complex balancing acts of economics and engineering. And I'm not sure that technology slogans promote a more evidence-based decision-making process. So to begin my conclusion, I think, therefore, that the industry, actually the customer, and therefore the citizenry, and therefore also the economy would be better served by a more incrementalist approach, a more modular and a more iterative approach. I always like to remind everybody that the E in LTE stands for evolution. And that's what I'd like to see technology progress as. So to stress, it's not that I think we should be investing less in R&D. It's not that we shouldn't be energized and enthused by what technological innovation makes possible. But I think we should be directing our resources on identifying and remedying those bottlenecks that are really hindering adoption, and not on perpetuating, what's frankly become a jamboree that helps contribute both to unrealistic expectations and also to spectrum issuance on terms and at a level of expense that has fundamentally compromised the mobile industry. So in short, let's have no more Gs. Let's have R&D, absolutely. But let's leave the hype cycle behind. Let's try and win back investors' trust. Let's have spectrum issued on more sensible terms. And let's refocus on identifying and meeting customers' real actual needs. Thank you.
Thank you very much indeed, Stephen. And some very good points. I think those who've been watching the markets recently will have noticed Vodafone announced a small increase in capex, very tiny percentage-wise in terms of overall spend a couple of weeks ago, followed immediately by a 7% drop in their share price, as investors decided even a small increase in capex was not what they wanted to see. So it's happening out there right now. Let's turn to our second defender of the No More Gs, and that's Phil Sheppard. Phil is now the Director and Principal Consultant at Clear Technology Consulting, but many of you will know him for his time at 3, where he was accountable for technology strategy and architecture, and led the definition of the network transformation for 5G. He was also responsible for Three's 4G technology launch, and indeed helped launch the UK's first 3G network. So he's been through many generations. Before joining Three, Phil worked at BT Labs on a wide range of R&D projects. Phil, over to you.
Thank you very much, William, and thank you for the invite to talk here today. Well, thank you for the introduction. And as William has already mentioned, I am actually a technologist. I am enthusiastically in favour of technology innovation. I believe research and development should always be encouraged. I spent 14 years in R&D myself, and I believe there are always improvements in innovation. So similar to Stephen, really, I believe we should be encouraging that. And none of this argument that I'm going to make, and I think that Stephen made, was to stop that happening. I'm also a big believer in standards and their continual evolution. I was a rapporteur at the ITUT. I was also a member of the ETSI working group. Adrian may be pleased to hear. I do, fully support those standards. I've been involved in almost all the previous generations. I was briefly involved in 2G, and I've certainly been involved, as William mentioned, in 3G, 4G, and 5G. But I think each of those previous generations arguably required a generational change in the way that they have happened. Each one provided a very fundamental radio, protocol, and other architectural changes in order to achieve a big step change in a capability that was very visible to consumers, and that consumers arguably needed to know that there was a difference. So you start off at 2G, obviously many benefits of 2G, but moving to digitalization, providing good voice quality, and being a global standard, it allowed roaming benefits, which were fantastic. I was involved in the launch of the first UK 3G network that introduced data at fairly high speeds, which is a big step change. 4G took that another step further with, I'd say, broadband type speeds. And 5G had, with IMT 2020, a very clear set of quite big goals, super fast, speeds, much lower latency, which has been a big achievement, and massive scalability as well. So arguably, I think I've supported each of those generations, and I believe that it was necessary to actually swap out essentially to the new technology. So after all that, and saying I'm in favour of all of that, why am I arguing for no more Gs? Well, there are 4 reasons that I'm going to lay out as to why I think we should now stop going up the number of Gs. The first one is the problems that are caused by each new generation. And those problems have to be balanced with the benefits that each new generation brings out. And probably the foremost problem that I see in a new generation, and certainly the way it's been done, is that of the lack of backward compatibility and device obsolescence that causes. I think that's pretty poor from a consumer's perspective for handsets, but they're quite fast moving and they churn relatively quickly, but still not instantly. But it's particularly unsustainable for long-term IoT and in industry deployments if you have to think and plan ahead that this is going to be replaced in the next few years. There are still millions of 2G and 3G devices in use, even in the UK, which is fairly ahead of the curve. And that's creating a significant challenge to both the networks in sunsetting 2G and 3G networks, have to maintain them for a lot longer than they really ought to. But also, to IoT vendors or IoT providers that have to churn out their kit. So Ericsson Mobility Report from 2020 said that in Western Europe, there are still 21% of connections that are only 2G or 3G, so they haven't converted to 4G or 5G. But other regions are even worse. In Middle East and North Africa, there are still 68% of connections that are 2G and 3G. So a long way from even making a big inroads on 4G, and certainly not 5G. And 5G is intended to support a massive machine type communication volume. So the intention is to have millions of devices with very high density. And if you then swapped it out for a new generation that wasn't backward compatible, it would make a huge, probably unfeasible effort in order to swap all that out. So just to give an example of that, there are 24 million smart meters deployed in the UK already, going up to around about 50 million by the mid-2020s. The majority of those, not all, but the majority are connected by 2G and 3G. So they already have a big problem on their hands. Most people, most watchers expect 3G to be sunsetted in the next 2 or 3 years and 2G to follow sometime thereafter. So there are big problems. And this is only, I say only 50 million devices, whereas 5G is thinking millions and millions more. The other problem that it creates, as well as that's probably the main one, I say the backward compatibility issue, but it creates some consumer confusion or potentially even worse, apathy. 5G hasn't really been quite the big consumer hit that people were hoping it would be. Certainly the marketing benefits didn't seem to really kick in as much as people hoped. And doing a new generation simply for marketing benefits, be it the vendors or the operators, doesn't seem to be justified. And the final problem it creates is, and this is definitely not a reason for not doing a new G, but I think it's a problem to recognise, it creates conspiracy theories. And we all know with 5G there's been some irrational conspiracy theories. Certainly the belief that 5G can create COVID is highly irrational. And then the unfounded, I'd say, belief that 5G also creates new radiation dangers. Not so irrational, but unfounded in terms of the physics that have been looked at. So I think they're some of the problems it creates. So if I go on to my second reason for not having a new generation, and I think this is about each generation really needs a clear reason for being a new generation. And the question is, does 6G have that? Doing a new generation simply for the reason that it sounds good and you want to market it isn't a good enough reason in its own right. So far, 6G doesn't seem to offer very substantial benefits over a wide area of coverage compared to 5G. But there are many concepts in 6G that are beneficial. Some of the very, very super high speed terahertz type ideas, many of the services and applications ideas, etc. But currently, it doesn't seem to have a case that says you should swap all your devices out over the wide area, all across the country. What is the rationale for that? And actually, you can add capability to an existing generation. 3G did that. 3G did that with HSDPA. 4G did that with 4G Advanced and carrier aggregation. And the same could be done to add all the 6G ideas into the 5G standard and extend it. So that's my second reason. It's definitely a clear reason. The third one is that, from a technical point of view, the benefits of further change, particularly in the radio access spectrum at the wide area coverage level, is becoming incrementally smaller. The efficiency, channel efficiency, is nearing the Shannon limit of capacity. The orders of modulation are already such in 5G that the number of instances where the signal to noise is good enough to trigger the highest level of QAM is very rare. And so, and again, also you could add more on if you wish to do so into 5G. Of course, techniques like spatial beamforming and advanced antennas would certainly benefit to increase the efficiency further. But again, that does not need a new technology. It could have been added to 4G. It certainly is added to 5G, and it could be continually to evolve. The bandwidths technically match the available spectrum pretty well now. So the sub-gigahertz spectrum bands, you can do 100 megs carrier bandwidth, and you can aggregate further, which likely reflects quite efficient use of the spectrum that's available. And the millimeter wave also relatively well served with 400 megs bandwidths and beyond. The architecture is also pretty well future-proofed. It's all software-based. It's all cloud native in terms of 5G standalone, virtualized, containerized, all those things, all IP, sliceable, etc. You can implement it in microservice. So all the buzzwords. Now, of course, that can develop and will develop, but again, doesn't need a new generation in order to do that. So that's my third reason, which the diminishing benefits of further generations. The fourth one, and this is probably quite key, some of the points Stephen was making, is what are called stability benefits. So if you have a stable standard, then it allows more vendors. So vendor diversity could potentially increase because they have that stability of what they're working to. The protocols and interface being more stable can help things like Open RAN and open services. It could encourage a larger range of devices because people have the long-term vision for their services and their devices. And particularly for IoT and long-term industrial use, it allows companies to plan ahead in the long term without this fear of premature obsolescence. So they were the 4 reasons. So I'm just going to sum up to the end now. So the 4 reasons that I have for not going to the next G. First one is the problems created with each new generation, particularly device obsolescence. The second one is the lack of a very clear reason for a new G. The third one is the diminishing benefits of each generation, certainly in terms of the wide area coverage at least, although I do acknowledge there are more niche cases which will benefit from new technology. And finally, the benefits of stability of the standard, stability of devices, etc. So my message is, yes, continue research and development for certain. Yes, continue standardization. Things need to evolve and change. But no, do not name a new generation 6G. Instead, focus on backward compatibility and then adding all this nice new capability under the 5G banner. I believe this will provide significant benefits to consumers, businesses, governments, and the industry, including allowing planning for long-term services with confidence, increasing service-based innovation, leading to greater economic growth. So that's the end of my argument here. I'd like to encourage you to vote. I think it's yes is the right answer in the survey, William, and I'll go back to you, please.
Thanks, Phil. And you're right. We do need to keep clarifying what yes and no actually means when you put a negative sort of main title. And I'll do that when we get back to the vote. And interesting that you picked up again on IoT. Obviously, that's something that Stephen picked up on. I see there's already a question or a point of view in the chat around IoT. So we'll certainly come back to talk more about that when we get to the discussion session. But now it's time to have the opposite point of view, that we should have 6G, and Adrian and Rahim are going to take us there. So we're going to start off with Adrian Scrase. Adrian is the CTO in ETSI. He's played a central role in many of its key aspects, such as the creation of 3GPP, where he's responsible for the operation of the project coordination group and the mobile competence center. He was involved in the formation of the 1M2M project, which was a particular IoT initiative. And he has more than 40 years experience in telecoms, including 34 years in standardization. Adrian, over to you.
Thank you, William, and thanks very much to Cambridge Wireless for inviting me to speak on the subject. I've called mine "Let There Be Gs," which is the opposite of the question, of course, you were posing. If we could please put my slides up. So let there be Gs. First of all, what are Gs? And Gs mean different things to different people. I understand Professor Mishadola was going to join this call, and I guess for him, with his right hand, G means 392 hertz, and with his left hand, it probably means 196 hertz. For me, it means da-da-dit. If you're a maritime guy, you'd be flying this flag to say, I need a pilot. Maybe true for EasyJet too. It's many years since I did semaphore, but I had to look this one up, actually, bottom right, I confess. The message signaling semaphore for G, left if you're Braille, and of course, the gravitational force in the middle. Conclusion being, Gs are all great things to have. But I suspect we're really talking about a different type of G. We're talking about the generation of mobile systems, which we've already heard have progressed from 2G to 3G to 4G into 5G. I think it's worth noting that the first GSM voice call took place on the 1st of July 1991, at least the first commercial call, which means that next week we will be celebrating 30 years of GSM voice. So we've had 3 decades then of generational use of these systems. And I take Phil's point that, you know, you've got an awful lot of acronyms here, and I make no apology for reproducing them on the screen. Now, Gs don't suit everything. May not be suitable for small standalone type systems which serve local markets, but my contention is that Gs are suitable for large complex systems which are intended to evolve over several decades and serving global markets. So my conclusion here, it's a matter of horses, or GGs, for courses. Doesn't suit everything. I say it suits the mobile systems. In terms of the structure of Gs and how they're being created, 3GPP is the de facto standards activity where mobile cellular systems are specified. It's been that way since 1998. On the plus side, I see that it attracts more than 700 members from 35 countries to do that work. ETSI is working there with China, with India, with Japan, with Korea and the US in a partnership. So this means that by definition, the intellectual input to this work is coming from an enormous reservoir of international experts. But I would also point out that 3GPP doesn't work in Gs, it works in releases. Gs just provide the framework around which standards releases are encompassed. By example, 5G is first composed by the releases 15 and 16, but will also include releases 17, 18, 19, etc. So I see Gs really as a sort of a big stick in the sand. It's a destination to which an enormous industrial effort is invested by stakeholders. And I would point out that these stakeholders are not just industrialists, it is academia and research bodies, it is governments, it is SMEs. 25% of 3GPP's membership is SME based. So it is a very large community of interest that's forming together to write these releases. And it's the sum of the releases that then form the next G. So in terms of timing, and I've heard the argument that we need faster innovation cycles, that Gs by taking a decade or so don't allow for more incremental evolution. I would argue the contrary, because the period for a G can be set. It's typically 8-10 years. For 4G to 5G, it was 8 years. You can set whatever period you like for a G. It should be market demand, really. I agree with that point entirely. But we also have incremental points between Gs. And you might want to note that we've already determined that 3GPP release 18 will be badged as 5G advanced. So 5G advanced has already been chosen as the marker which will be used for the midpoint generation, that being halfway between the 5G we have now and the 6G which we're likely to get around about 2028 to 2030. In terms of deployment of Gs, because Gs are written by a very large community of interest, there is an inbuilt readiness to deploy those results. And if we look at what's happened with 5G indeed, and the completion of release 15 and release 16, that work was completed in 2020. So I think it's a bit early to be saying 5G hasn't been a market success yet. What we can note is that by April this year, though, we already had 163 commercial networks launched in 64 countries. So I think it would be hard to contend that we haven't got off to a very good start. Moreover, GSMA forecasting that by 2025, we expect to have 1.8 billion 5G connections. So what we're seeing here is that by the use of Gs, we are heading towards deployment on a grand scale. And if you look back at 2G, 3G, 4G deployment figures, there are some quite staggering figures, not just in absolute terms, but also in rate of growth. And I think there's testimony there to show that in many cases, we see rapid deployment and very fast take-up. I'm not looking with a myopic UK view here. I'm looking here globally and looking at 5G in terms of its global success. In terms of research, and we've heard that research is important, I very much buy into that. In terms of ICT research, this tends to be a very long-term activity and one that needs to be carefully planned and programmed. So ICGs provide a focal point for research agendas. But once the research results have been obtained, you don't actually have to wait for the next G to feed that work into standardization. You can actually feed that work into the next release. So you're not obliged to wait to the next G to actually get benefit from your research results. If we look at what happened in 5G context, the research agendas were established involving very large communities of academia and industry. And I think the fact that 5G had a very clear timeline gave you a focal point for when those research results had to be obtained by. If you miss the deadline, it's going to be too late, basically. So considering that research is a long-term thing, researchers have to have targets to aim for by which their work needs to be complete. And I see that Gs are a very good instrument in helping to achieve that. Moreover, historically, Gs are not late. Sometimes they're early. 5G was delivered 18 months ahead of schedule, but they're rarely late. So you have a dependable timeline. You know when the next generation is going to be put to market, and that helps you then to aim your research and development results in a clearly focused way. To do that research, you need large amounts of money. Now, because you have a very dependable timeline, because you have such a large community of interest, and because Gs are seen as rather stable and probable things to happen in the future, it's become easier to attract research funding. So if we look at what happened for 5G, we had an enormous amount of both public and private money pushed into research projects. And if you look what's happening already with 6G, and it's really early days for 6G, but these are just some of the public figures I found for declared 6G funding for R&D. The US, $600 million, Japan, $380 million, Korea, $200 million, Finland, $250 million. If we look at the EU, 900 million euros pledged over 7 years. So because these Gs are seen to be very tangible things, there is the possibility then to attract this large funding of R&D, which is absolutely essential for driving innovation. Having great inventions is fine, but you also have to sell them. There are very good examples in the past of tremendous pieces of engineering that were never market successes. And I see that Gs actually help by providing a marketing and a branding wrapper. The G concept seems to be quite widely understood, at least by the populations. People tend to think that 5G is going to be better than 4G. They want one because their neighbour's got one. In effect, there is an element of competition, I think, that is inbuilt by the use of the G nomenclature. And if you just look at what the UK operators are doing, I'll put the links on the screen. They are all positioning their wares in terms of 5G. They're explaining to their populations why 5G is something that people should upgrade to and what they will get as a consequence. So I think it really helps the operators putting their products to market. And to a certain extent, what we're doing here is actually creating market demand well before the standards are complete and before the products even become available. The Gs have also become political instruments. Many of you will remember when David Cameron announced that the UK was going to be the first country to deploy 5G. I've no idea who advised him to say that, but he did say that, and he actually lost his job a few weeks later, but I think that was for a completely different reason. The point I'm making, though, is that by having this sort of G wrapper, it captures the attention of governments. And just look how much public money has been pushed into 5G deployment in the UK in the form of catapults, test beds, trials, incentives, deployments. An enormous amount of government money is being pushed into this because governments buy into the value of the G. They see this as a way to improve their GDP, to modernise their industry. And, just as an example, I've looked at the Worcestershire 5G consortium, and, you think what a great example of how a generation of technology can help to try and lift what should be our manufacturing hotbed in the centre of the Midlands of the United Kingdom and try and bring that up to the 21st century. So I think all of that is aided by the fact we have this generational approach. It would be much harder if we were just working with incremental bits of innovation. But as we know, everyone's already talking about 6G, and I must say I'm personally rather surprised that there is so much discussion on 6G when the ink on the 5G standard is really still drying. Nevertheless, on the screen here, you can see a whole load of public documents by family names, both from vendors and from operators and from some very good universities, including University of Oulu and the University of Surrey. And if you look at these documents, these aren't sort of broad visionary views of what 6G are going to be. If you look inside, they actually have some very, very detailed understanding of where they think the technology should be going in the next 8 to 10 years. Of course, it might not happen. That's the whole point of research is, you know, you have plans and your plans may adjust depending on your research results. My contention is, though, that, you know, already you have a large proportion of the world's academic experts looking at where we should be going and how we should take this technology from 5G we have now to the 6G that we're going to have around about 2028, 2030. Time for me to conclude then. I think Gs have served the mobile industry very well for more than 3 decades. I see that Gs really provide focus for research and for investment. Gs provide a branding wrapper which populations understand, and it helps the operators put their products to market. But finally, I would say that, you know, if industry decides that it wants to stop Gs, and it is an industry decision, it's not going to be ETSI or Cambridge Wireless that decide whether we have Gs or not. But if industry at large says, you know, we're going to stop this generational stuff, my contention is it's too late for 6G. The genie's out the bottle. You know, that train has already left the station. There is so much talk about 6G that if you want to have this change of approach, I think the earliest opportunity you can do that will be with 7G. So my contention and conclusion is let there be Gs.
Thank you very much, Adrian. And some very impressive numbers for the amount of money flowing into research from government and other institutions. Okay, time to turn to our final speaker before we open it up, and that is someone who I'm sure all of you know, Rahim Tafazolli. He has been the Professor of Mobile and Satellite Communications at the University of Surrey since 2000, the Director of the Institute of Communication Systems since 2010, and of course the founder and director of the 5G Innovation Centre, which was formed in 2012. He's got over 30 years of experience in digital communications research and teaching, and has authored and co-authored more than 500 research publications. Rahim, over to you.
Thank you very much, William, and thank you very much all the colleagues, including Phil and Stephen, for helping and supporting my argument. And I think Adrian has made my job a lot easier. So I will not go through every lines on the slides I provided. It is mainly for the information and reminding ourselves of some of the technologies. But the focus of my talk is we need to know what 6G is before we reject it. I think we haven't discussed that, what 6G is. And hopefully I will say what is 6G and what is not 6G. And this is a projection of what Adrian has said. The standards, even 5G, is evolving. At the same time, within 3GPP, at the same time, ITU started research, and it will focus on the study items on 6G, and hopefully by 2030 plus, 6G will be available. So just to remind ourselves, 5G has achieved a lot through release 15, release 16, and etc. And it is continuing and provides higher speed. It is not just higher speed, it is higher capacity. Is a big difference between the two. Mass connectivity, reliability, and low latency to address industrial application of the wireless connectivity. And it's going on. It is not stopping. I have to mention this one, that when we talk about one generation to another generation, doesn't mean that previous generation stops. Even now, 4G is evolving, and 5G will be no exception. Will it be evolving within that framework and through future generation, like release 16 and also release 17? We'll see huge amount of enhancement on the uplink capacity, on FDD part on the low latency as well as the mass connectivity side. So the wireless connectivity through generation will evolve from previous generation, which is people-centric, more towards more people and machine-centric communication, and including more and more automation through artificial intelligence and machine learning, as well as edge computing. So what is going to be next? What is going to be 6G? I'm a believer that always all the generations were reflection of the market demand. And I don't, as somebody wise said, we don't need to look into crystal ball to see the future. We need to look at the past to see what future should be. Why is it a reflection of always societal demands? We started the voice telephony on the move. And then we went through higher data rate, as Phil said, 3G and 4G. And then 5G is more about automation, taking into account industrial requirements for modernization of industry. 6G, unfortunately, COVID-19 taught us a lot of lessons. And it will be social aspect, requirement, demand, environmental demand, as well as industry. And that is how we based our 6GIC vision and strategy for the next 10 years of the research. So I have to mention here what is not 6G in the view of the way that 5G is evolving through release 17, release 18, and we could have release 19 and 20. 6G is not new business models, something that Stephen mentioned. We need new business models, but it doesn't mean it is a new generation, especially business to business model we need. IoT, you mentioned cellular, IoT, and etc. 5G and AI is not 6G, definitely. It doesn't constitute another generation. Open RAN, it is not 6G. Achieving higher speed, 10 times or 100 times more speed, doesn't really justify calling it another G. Or even adding more security to the network, it doesn't mean it is another generation. So from 5GIC point of view, the vision that Adrian mentioned, it has been published, it is on our website. We start with a clear business case and a use case. That is our strategy. And lessons we learn, we don't want to specify any target KPIs. Through the use case and the business case, the KPIs will come out. At the same time, we consider the 5G capability towards full 5G through its evolution. The focus of our research is societal and industry challenges. And that's productivity, sustainability of environment, and overcoming digital divide, which I think Phil mentioned to some extent. But on the communication media, if you look at the way it evolved, 2G, if you remember, with the text and ringtones all the way to two-dimension video, and 5G enabled three-dimension video, which is virtual reality or XR. And 6G, in our opinion, the media will evolve into fourth-dimension video in order to provide, underline this, interactivity between virtual and physical worlds. Interactivity is the key, which I will expand on that one in a minute. So if you look at this video, which is three-dimension video enabled with 5G and fiber that we had, this person was holoported about 50 kilometers from London Excel, actually, into our building in Guildford. So what you see here is three-dimensional video, and we were talking to each other.
Can you see me?
And we are transmitting two of the human senses, vision and hearing. What I couldn't do here, I couldn't shake hands with this person. I couldn't work with him in synchronization. So what we need to add other information to this video, which we call it ambient information. We need to sense the information. At the same time, from the technical point of view, to provide that interactivity, we need high quality time and frequency synchronization, which I will expand on that one within the time allocated. So 5G introduced to us low latency, and that's justified calling it another generation. 6G, in addition to low latency, time synchronization and frequency synchronization is the differentiation. And if you have that, it will take most of the 5G application to completely a new level of interactivity. For example, with 5G low latency, we can have connected vehicles. With 6G, with a low latency and time synchronization, we can have cooperative driving. We can have driverless cars. Cars can move at a high speed by synchronized. All the way, for example, health. We can have interactive health between GP and the patient at home. And effectively, we are turning a science fiction of the teleportation into science fact through interactivity and fusion between virtual world and the physical world. We need to address the environment issues and the coverage, I think the Phil mentioned before. We need to take advantage of new type of material, reconfigurable, reflecting surfaces based on the metamaterial to provide coverage cost effectively and energy efficient manner. For example, we built such a system last November. We demonstrated this to extend the coverage by 15 to 20 dB gains with no extra power source, no power, input power at all. And that static version provides outdoor to outdoor coverage, outdoor to indoor coverage, or indoor to indoor coverage. We need to look at remote areas. There's horses for courses. We cannot provide cost-effective coverage only by terrestrial means. We need to look at the upcoming mega constellation low Earth orbit and integrate it within the cellular wide area networks. The challenge here to provide direct connectivity to the mobile phone, to user phone. And that is a technical challenge. So that the person, doesn't matter whether it is under the satellite or it is non-terrestrial or terrestrial systems, it uses the same phone and the same services. We believe that 6G will be a network of network. It will shift the focus from pure communication to communication and sensing and integration between the two. Why is it network of networks? The short-range network is to provide and collect ambient senses, ambient information. It could be terahertz. Wide area cellular networks and the very open areas through the satellite. The three major components of the future networks, but they need to be integrated seamlessly. We have identified a number of research enabling technologies underneath, but our focus is, if you want to compare with the 5G, the same triangle, the focus is coverage extension, cost effectively, time and frequency synchronization, and geolocation information. Use AI when it makes sense, in the network, on the wireless, on the services, wherever it is. There's a huge amount of research issues that we have identified. So I'm not going to go through each of them, but our white paper on that is quite clear. So by 2026, most of the releases on 5G standards will be complete and the service will be available. Then the focus is 2030 plus for 6G coverage to overcome digital divide, environment sustainability, synchronization for 4D, physical and virtual world interactivity, edge computing and processing, geolocation for new advanced services, real-time interactive services, and contact tracing and broadband to remote areas. So why we need a G to do all this? 5G and its evolution can always provide higher speeds. I think, I don't know whether it's Phil or Adrian mentioned, we can always add more bandwidth and go for bigger massive MIMO system. We can provide higher capacity. We can add AI to make it more automation and do edge computing, better security and better energy efficiency and better coverage we can do. But we cannot do with 5G time and frequency synchronization. This is not inherent design of 5G. We cannot do sub-centimeter location, indoor or outdoor. We cannot provide interactive virtual and physical world system. We cannot do dynamic coexistence and spectrum sharing. Network of networks, integrated sensing and communication brings completely a new dimension to the way that we've been communicating and extending the coverage. Things like reconfigurable intelligent surfaces, distributed massive MIMO, cell-free architecture, they all require new radio access network architecture. So I just want to finish this. We've got 30 seconds left to say that most of our vision is documented in this white paper that you can download it from our website. And I think Adrian mentioned to this one. And also I want to bring your attention the Tech UK and DCMS workshop that we are organizing on the 1st of July, which is the anniversary of the first GSM code, as Adrian mentioned. And that is to look at advanced radio access network techniques. It is all presented by UK universities. There is no industry's presentation. And there is a whole raft of new innovation, new techniques will be presented here. I'll encourage you, this is free. I encourage you to register and join the conversation. Thank you very much. Thanks, William.
Thank you, Rahim. Thanks to all the speakers. So now we've got about half an hour for sort of general discussion and chat. Please do feed in your questions to the chat. I can see them coming in, and what I'm going to try and do is blend them in to sort of broader questions as I go through this. So I guess one thing that struck me was, I think it was Phil that said, what's the reason for 6G? He couldn't see a clear one. As Rahim was talking, it struck me an awful lot of what I heard was what I'd also heard for 5G. It was going to be more environmentally friendly. It was going to have high capacity. It was going to deliver a lot more. Connected cars, for example, were going to be available. So it kind of feels like, did perhaps 5G not hit the mark properly and 6G is needed to actually deliver what 5G promised? Or is there is 5G actually performing as expected and going to deliver everything that we thought it was? In which case, it's not quite clear what the real incremental for 6G actually is. So probably over to sort of Rahim and Adrian more than others, but anyone's welcome to chip in on that front. Is 6G needed quite quickly actually to deliver what 5G aimed to but didn't quite get there? Or is it really something materially different from 5G?
Adrian, do you want to go first or should I?
No, you go first and I'll pick up.
Okay, I just want to remind everybody that for energy efficiency point of view, there's a report by the German Ministry of Environment and compares energy efficiency of video transmission using 5G versus 4G versus 3G versus 2G. I can't remember the numbers, but 5G is by far most energy inefficient than previous generation system. So that idea hasn't been abandoned. What I said here, if you want to extend the coverage, which is the major cost, major contribution towards energy consumption, what can you do energy efficient? Extending the coverage. And that's why I mentioned the RIS, reconfigurable intelligent surfaces, as well as we need to open our minds to use other systems like satellite communication, non-terrestrial system together with the terrestrial system. Then we would need to find out how much we can increase the energy efficiency, cost efficiency of the system. And I hope for 5G, one of the sides of the triangle I mentioned, coverage, doesn't disappear over time, and coverage becomes one of the major targets towards the 6G system. Sorry, Adrian.
I think I would just add that when you set the big vision for what a generation is going to deliver, it's described in terms of when that generation is at a state of maturity. So the vision isn't what you're going to get on day one. And I will come back to my point that actually when the 5G timeline was set, we didn't expect deployment until 2021. So deployment has happened much faster than was first predicted. And you've got two choices. Either you wait until the technology is matured and then deploy it, or you deploy it and mature as we go along. And industry tends to want to get to market fast. And then, of course, over the coming years, it will reach some state of maturity. So we shouldn't expect to see, the full vision of driverless cars and non-terrestrial networks and nuclear power stations being run by 5G in the first year of deployment. That's not going to happen. But the expectation is that you will see that maturity by the middle of the generation, around about 2025, 2026. And that's what we should be looking out for.
Thank you, Adrian. Phil or Stephen, any thoughts from you on that one? Did you hear the reason you were looking for 6G?
Will I comment, Stephen, first? So yeah, no, I mean, there's some good arguments there. I can't deny it. There's some good research there that definitely needs to happen. I think the argument that we'd have is that we need to focus on the ability for people to plan, the customers, the consumers of this, to be able to plan their services in the long term. So there may come a point where the RAN architecture needs to change, and that may require a big shift of all these devices in and out. But I don't think that's the focus at the moment seems to be on aspects of things like funding of research, political or other reasons at the moment in terms of marketing to do that. So back into the point about has 5G hit the mark, I would entirely agree that you can't expect that 5G will meet all of its objectives on day one. It will be an incremental improvement. So let's see how far it can go. Let's focus on backward compatibility and then see when or if you need to swap things out for another generation, and try to focus on that ability to maintain a long-term stability is the argument I'd make.
Stephen, anything you want to add there? You're on mute at the moment, Stephen.
I almost apologise for the facile nature of my argument, but I come back to this point. I mean, tremendously impressive presentations from everybody, going into far more detail than I did on the capabilities of the various technologies. But we need to return to this fundamental point that what we have is already science fiction. To quote Arthur C. Clarke, it would already be mistaken for magic, and yet it hasn't hit the mark. And I mean, of course, I don't have a crystal ball, but I would be astonished if in 3 years' time people were to say to themselves, what, that 5G, well, it was a bit of a slow burn initially, but wow, look at those industry revenues. Now there are many contributory factors to the industry's top line malaise. one might cite regulation and merger control policy, for instance. But ultimately, that it's a pretty good litmus test for whether or not our customers, the people for whom we are here, are actually seeing things that they regard as essential and providing utility. And that side of things, I'm afraid, has been really pretty disappointing. You alluded, William, earlier to the response of investors and seeing a capex hike. Well, in industries where investors have an expectation that the incremental capital will result in services that are enthusiastically embraced by customers and their wallets, you don't actually see the share price take a ducking because more capital is going in. But I mean, with telecoms, that's just been the way it is for the past decade and a half, or perhaps rather longer. So I come back to this this very fundamental point, is that what we have is already great. What we need to show is that that IoT capabilities as they are today, albeit primitive by comparison with what 6G might offer, can nonetheless get customers excited and generate growth. If we can do that, I think everybody would be happy. You'd actually have investors encouraging and welcoming further rounds of Gs, but that's not where we stand today.
Thank you. Can you still hear me? Because having said I was well connected, Zoom just crashed on me. Am I still here? Good. So let's pick up on one of Stephen's points then about IoT, for example. So IoT has been put forward as a really important element of 5G. It's one of the 3 pillars. But what we know is that IoT historically has been very disappointing. So back in 2010, 2011, Cisco Ericsson said that we'd have 50 billion IoT devices connected by 2020. The latest figures I've seen suggest we've probably got about 8 billion connected, so less than 20% of the forecast. And of those 8 billion, probably more than 7 billion are in the home and the office, and they're not connected over cellular, which is fine. They don't, it's not a bad thing, but it's not been a cellular driver. 5G aimed to correct this, I think, primarily through throwing technology at the problem. And it sounds like 6G is kind of going to be more of that. Do we think that's really the answer to this, or is it actually stability and business case and customer case that works through these processes? So I guess Rahim and Adrian, perhaps to ask you that question first, because it sort of challenges the view that more technology will solve slow take up in certain areas.
And I was actually going to make a point following on from the previous question, but it very much aligns with this question too, because I think we're sort of making an assumption that the 6G landscape is going to look very much like the 5G landscape, and actually I don't think that is true. I think if you look at some of the big pieces of work that have taken place in the standardization arena and how they're likely to impact on the landscape, and here I'm thinking of, for example, non-public networks. Now, I think with the introduction of non-public networks and the interest we're seeing around them and the trials we've got going on in the UK, I think it's quite likely in the future that the so-called operator will not be the same as the operators we know and love today. I think it will be a very different landscape. If you add to that the 5G and unlicensed spectrum, for example, I think in terms of factory automation, we're seeing a lot of interest, at least from the manufacturing industry, to look at 5G and say, will this improve our productivity? Will this enable us to revamp our manufacturing floors faster so that we can make more profit? And if the answer to that is yes, I think you will see IoT figures driving dramatically through factory automation and other sort of digitization of industry, if you like. But again, it's early days. What's pleasing is that the results of early trials and early deployments are very impressive indeed. And I've been talking to factories in the last 2 or 3 days, in fact, about this very subject. And these guys aren't going to change anything unless it makes them more productive and more profitable. So they have to be convinced that that is the case before they take the plunge. But I think we're seeing early evidence that they are going to take the plunge because they do see the benefit of a predictable radio over something like Wi-Fi, which is not suited really for, you know, a huge automotive manufacturing plant. So I'm rather positive about the future of IoT because I think the landscape in the future will look very different than the one we have today.
But do you think we need 6G to come along, whatever, in 8 or 9 years to have a new IoT solution, or will that destabilize those manufacturers that are thinking of investing in the next few years?
It's going to be NB-IoT over 5G, exactly what we're doing now. NB-IoT over 5G NR, exactly what's being standardized as we speak. There's no need to have yet another IoT radio.
Yeah, makes sense. Anyone else want to come in on that one?
I just want to add this point. I mentioned in my presentation, but I think that's, I get this impression that people think that when the new G comes, the previous G is abandoned. It's not the case, as we know. And especially with 5G, because it's virtualized most of the system, it is mainly software for the flexibility. And 6G, 7G, whatever comes, will follow this paradigm shift, the way that we implement the equipments and the functionality through virtualization. And I believe that flexibility through virtualization and the flexibility of service-based architecture that 5G has, 6G will be an evolution of the 5G. It will not be, in my opinion, it will not be a revolution. It will be a revolution in terms of the services, interactivity between virtual and physical world. But in terms of technology, it will be evolution together with added time and frequency synchronization. I think that's, and to answer Phil's question, I think Adrian can back me up on this one. The backward compatibility has always been at the back of the mind of all the standardization activity in 3GPP. And the first thing that is considered is the service in 1G. In 1G, it can be migrated to the next G. It's always been the focus of the standardization.
Thanks, Rahim.
May I come in there, perhaps, William? And,
yeah, sure.
Obviously, some very good points made there. The issue I've got for IoT is that there's a couple of reasons I think why it hasn't really taken off. There's probably many reasons. One, actually, you know, the standards change relatively frequently compared to the devices that are going out there. So it's very difficult for somebody to plan what technology they will use. And therefore, actually, proprietary IoT technologies, which have been more stable, have been used quite a lot in the last couple of decades. And actually, whilst they look at backward compatibility, you have a real issue now with devices that are deployed, like the smart metering that I mentioned, which are reliant upon 2G and 3G. And 3G is what lasted 18 years and probably is going to last 20 years, and that will be switched off. So for certain, they've got a physical problem of devices deployed and no longer compatible with networks that will be run. And even 2G is being scaled down and probably will go, and that's been a longer running thing, will go as well in the next few years. So I think there is a real problem if you don't consider what the end users are for IoT and industrial applications. And that's probably my main problem with the 6G, using 6G as a means of essentially swapping everything. If it's purely incremental and it maintains backward compatibility, great. But that hasn't been the case that I've seen in the last few generations.
Yeah, I think as well, there's sometimes, even if it is the same, and Adrian mentioned 5G effectively just takes NB-IoT and moves it along into 5G. But that message is not very clear. But the message, in fact, is quite the opposite. The 5G enables millions of connected devices per kilometre squared, and therefore it must be different from 4G to do that. And that message then flows to manufacturers who think, well, I better, I better not deploy any NB-IoT because 5G is going to come along and make that completely redundant. And in fact, I better not deploy any 5G because 6G will come along soon and make that redundant. And so even if that's not the truth, I think there is a message issue, which kind of brings me to the next question, I guess, which is a number of you have rightly mentioned just how much pressure there is behind 6G, how many politicians are involved, how many research institutions, just how much global interest there is at the very highest levels, which of course we saw to some degree with 5G, but it does seem to be even more so with 6G. And I think some of that is now because it's become part of our geopolitics. It's part of the whole China versus the US kind of thing that's going on. And that raises the stakes dramatically. And that could be a good or a bad thing. So, on the plus side, enormous visibility, potentially significantly more funding. On the downside, it might be now that the standards are being driven more by geopolitics than by end user requirements. Any thoughts on that from anyone?
Well, I guess as the standards body representative on the panel, I have to say something. But what I would say is that from a standardization point of view, we are very aware of what's happening at a geopolitical level. And we are absolutely resolute in making sure that geopolitics has no play within the standards meeting room. So if we ever allow geopolitics to start to interfere in standardization, then we're on a very slippery, slidey path. So we take great steps to ensure that at least the standardization committee room, albeit a virtual room these days, is a place where you are treated equally, irrespective of where you come from. And if there are any other influences that are needed, they take place outside of the standardization arena. But you're absolutely right, William, in saying that the spotlight is now shining on 6G, and it's getting attention at the very highest levels of government. That's why so much research money is flowing into the business, which I think is absolutely tremendous, because right now we need our researchers to be properly funded in all spheres of science and technology. And just look at the great things we've done in the last 5 to 10 years by having this massive approach to R&D. So, if the only thing you get out of G's is a massive R&D agenda, then I think that's probably worth paying the price for. Personally.
Thank you. Who else would like to jump in, perhaps on Phil or Stephen on the counter side?
Well, I mean, I guess one obvious counterpoint to that is that it also comes at tremendous expense to the industry. Right? It comes at phenomenal expense, in particular in terms of license issuance. And I wonder whether net all of this is good for the industry and the economy and its citizens, right? Because we've created a situation where investors are extremely downbeat on the sector, primarily because what they regarded as a capital sink. Right, it's just always requires more capex, more funding for licenses, and they don't see that rewarded with gains at the top line, let alone the bottom line. So I think that I don't want to suggest that there's never a place for governmental or policy intervention. Plainly there are externalities in all these considerations. It's a very, very complex system. But I do think that everything needs to be joined up. And I would certainly say at the moment that, if you were to ask the typical investor about policy towards telecoms in general and the regulation of telecoms, it's a pretty confused picture. There are lots of statements about being pro-investment, and indeed often there's funding. But alongside that, you have decisions taken that make it much more difficult to justify the heavy investment that's involved there. And I've mentioned, obviously, the regulation and merger control policies, 2 examples of that that I think are particularly obvious. So yeah, this one is very nuanced, but we need to consider how all the slogans that are inevitably associated with what is in part, as you yourself said, is a marketing project of a new generation. We need to think, does that really contribute to the best policy decisions? I mean, I remember hearing, for instance, with 5G, that it was, I mean, I think literally, quote, the most important development since the Industrial Revolution, unquote. Now, this was the kind of conversation that was taking place in certain policy circles. In my view, that is an overstatement. However impressed I am with the new technologies on display, this is not as important as the Industrial Revolution. So, is this, is using these banners, is that likely to get the best policy decisions? I'm not sure.
And that sort of brings me to a question I saw in one of the chats, which is, who is 6G for? Is it for the end users? Is it for the operators? Is it for the manufacturers? Is it for the academics? Is it for the politicians? It's easy, of course, to say, well, look, it's for everyone. But if we look at, as Stephen's rightly said, at 5G at the moment,
we seem to have lost William.
Should we, Adam, can you hear us? Yeah. Should we attempt to answer his question actually about who this is for? I'll have a go. So I think that's the main point. I guess I'm also trying to make here is we need to justify a new generation based upon the benefits to the end users. And I'm struggling here to see what the message is to the end users, particularly when you're talking about IoT, embedded devices, industrial applications. Are we saying that we are committed to this technology for the next 20, 30 years, such that they can plan, embedding this in all sorts of things, vehicles and industrial applications that may sit there for ages? If we can't give that clear message here, and we're saying, well, it might all be thrown out in 6G, and you might then eventually end up with the network being switched off like you are with 3G and eventually 2G, then I think it's difficult for people to plan their services and grow their businesses. So I think that's, I think it's all great. And if we can justify this in terms of end customer requirements, and then let's do that. But at the moment, I see that messaging is missing, really.
I'm back. Sorry, my PC crashed. I'm having no end of excitement this afternoon, but hopefully you can all hear me now. And I think you were just talking through, hopefully, the remnants of most of what you got with my question, which was kind of, is this really going to benefit the operators? And if so, how? Or to a point I think Adrian made earlier, are indeed we're looking at a brand new generation of operators for 6G, in which case we may not be so worried about benefiting the current operators, although that in turn raises questions around how we get widespread deployment. Anyone want to have a go at that? Or who hasn't spoken yet want to chip in on that one?
Well, look, I mean, I'll just say that I'd love to see IoT making greater inroads into our industrial base, right? I mean, that would be a powerful vindication for the technology, and it's something that could well take place without the operators' involvement, right? I mean, that's an interesting question. The operators would still bring considerable expertise to this area, such that they might be the type of person to whom you would subcontract if, as a manufacturer, you felt that running the wireless platform weren't your core competency. On the other hand, you might go direct to a vendor, perhaps new entrants appear in this space. But forgive me for sounding like a bit of a broken record. Ironically, part of my enthusiasm for IoT is that it is obviously such a good idea, right? And I really do believe that there ought to be widespread popular applications of this stuff, which ought to be embedded across wide areas. Right now, this is the cellular operator's kind of core competency, right? And therefore, I think that whether or not all IoT falls under the remit of existing cellular operators, I think there's certainly a lot of IoT applications that obviously make sense to me that ought to be the natural playground of the existing operators. And as I say, it's not by no means the only question to ask here, but I think the failure of IoT to gain the traction that its original promoters, had forecast, does, for me at any rate, ask very serious questions about, what is it in all this that we're missing? Because somehow we're failing to energize and connect with a lot of potential customers who you just don't see, for whatever reason, the utility, or for some reason think that the implementation cost and hassle is too high. But to my mind, that's what we need to focus on, because that's the real hurdle, rather more than further refinements to the modulation scheme or what have you.
Thank you. So I'm going to pick up one last topic before we get to summing up and final vote. A number of people have commented in the chat, and also a number of you have mentioned it, that the coverage of the digital divide is also an important issue to resolve, that 5G, at least so far, has not done anything to improve coverage, and that we need to do something. I think, Rahim, you mentioned that maybe LEO satellite systems are part of the solution to that. Others have talked about network of networks. And those all sound good. I think the question is, do we need 6G for that, or will the LEO systems happen anyway, and we'll be able to access those just through an evolution? Or is there something within 6G that's important to achieve more widespread coverage, overcoming the digital divide that's just not available unless we have an improvement in standards? Do you want to start, Rahim? Because it's sort of
I mean, it's no, there's lots of low Earth orbit and V low Earth orbit satellite is coming up, and they are far from, and some of them are using 5G neo radio and 5G core network as part of the solution. And there's two major problems. They're not fully compatible using the same device everywhere you go. You cannot even close the link budget to get to this mobile phone. And another factor is, apart from the coverage, for them to be cost effectively compatible with the terrestrial deployment, is the capacity per kilometer square needs to be at the same cost as the terrestrial systems. So there's all of this boils down to some technology challenges. I don't know, because I was going through my slides very quickly, and I think if you had the sharp eyes, you would have seen I mentioned about space MIMO. We have some idea that we can break through all of these technical shortcomings, that to make the satellite one a little more in terms of capacity, in terms of the coverage. I think it's more competitive or equal competitive with the terrestrial means. So yeah, I think that's the answer to your question. But if you have time, I would like to answer Stephen about IoT later on.
I think we'll probably have to pass on that one, unfortunately, but I'll give anyone else who wants to quickly chip in on the coverage a chance to do so.
I'd like to say a couple of words on coverage, but in a 5G context, just to bring the participants awareness to the fact there's a study ongoing right now in 3GPP on how 5G NR can be enhanced to provide better coverage. So, what are the clever things we can do with the radio interface to improve coverage, both indoor and outdoor scenarios? And maybe the coverage indoor is just as important in this context, because, if we're going into factory automation and IoT and industrial applications, we really need to get to grips with providing coverage in metal warehouses and things like that. So the study is TR38830, if you want to make a note of that. It's a release 18 study, so it's early days yet, but there's a lot of advanced thinking on how we can improve coverage in a 5G context. And as Rahim says, we will then evolve to 6G and hopefully do an even better job of it there.
Fantastic. Okay, I think it's time to bring up the vote again and see if that's changed whilst I make a few final remarks. So just to remind you, go to slido.com, same place as before, same number. And the question is, let's have no more Gs. So if you agree that there should be no more Gs, then you answer yes. So yes means you don't want 6G. No means you do want 6G. And we'll let that run whilst I just blather on shortly, and then we'll see where we got to. So first of all, enormous thank you to all four of our participants. That was a really good debate. Lots of really good points made. And I think, a lot of agreement, despite the fact we framed it as a yes-no kind of thing. I think we all agree that research is critically important. We all agree that technology improves all the time, that it's already fabulously strong, and we'll get better, and we need that. And I think we also kind of all agreed that it's a mix of evolution and revolution. So we've talked a bit about how there will be many evolutions during 5G Advanced and so on, which will evolve, and then 6G at some point coming along. So it's not just, we do 5G, we do nothing, and then we have 6G. So I think we all agree with that. I think where the differences lie are to some degree around whether this should be driven through its current process, which is sort of led by all sorts of entities, but also involves high-end politicians and so on, or whether we should take a step back and look more at what's gone well and what's not gone well in the commercial world, and understand the fact that operators and others are not doing well, and actually something that works economically may be as important, more important over the coming years than a leap forward in technology. But clearly lots of nuances here and a very finely balanced argument. But it looks like the voting is stabilizing-ish. So to remind you, when we had the original vote, we had 63% voting yes, as in we don't want 6G, and the opposite 37 no. So it looks like we've actually gone further towards no more Gs. We're hovering at about 71%, so up from 63 to 71. So not an enormous change, but a slightly more people thinking that we perhaps don't need 6G. Fascinating. So big thank you to everyone who contributed in the chat. I did try and feed in as many of your questions as I could, or at least I used them to help inform my thinking. That was really valuable, really useful. Oh, 69 to 31, just at the very end. But anyway, I think the A's have it. That's it from me. So thank you ever so much to all the speakers. Thank you to everyone who's been listening out there. I think we had a pretty big audience today, and look forward to the next one of these, hopefully in not too distant future. And that is me done. Thank you, everyone.
Thank you.
Thank you, William.
Thank you.
Thank you. Bye.